We decided to make a robot design with modular attachments. We based attachments on what we needed to do: move around the field, collect and shoot particles, push the beacon button, and lift the cat ball. This way, if we could change out attachments later if needed.
My name is Joshua. For the chassis, we had two likely options. The first option was to do how we did it last year, which was simple, cheap, and easy to program. We also knew how well it worked already because we used it last year. Next up, a brand new idea was the mechanism wheels. The mechanism wheels would allow us to move sideways. Since we were no longer a rookie team, we felt we could step it up, so we chose the mechanism wheels. Moving more precisely could be done with the mechanism wheels, which is very important to this game. The only problems were that they were more expensive and harder to program, but we overcame that. The mechanism wheels were obviously the best option.
Last year, the beacons were very important. This year, they are just even more as important. We considered a bar, a wheel, or rack and pinion sliders. Also, we briefly considered using a curved surface at the height of the buttons. The bar would be simple and would require no moving parts, but it would have to precisely line up the robot, and it would be tricky to have a bar extruding from the robot. A wheel would be simple and would work nicely with our mechanism wheels. At least, that is what we thought. The mechanism wheels we found to be inconsistent moving sideways for the wheel. Finally, what we used last year, the rack and pinion. While it requires two moving parts, we knew how to use it since we did it last year, and from that aspect, it was simplest. We also used the white line to line up our robot. We found that an optical distance sensor was more accurate than a color sensor for reading the line. This year's game brought a new element to us: shooting. Once again, we narrowed it down to two options: a catapult and a double-wheel shooter. We found the double-wheel shooter to be easier, as we could continuously shoot. Many wheels were tested, and we found that big rubber tires were the best. We modified the gearbox of the motors so we could shoot far enough. We modified the gearbox to make it a 4:1 ratio, with 4 being speed. We engineered the angle to be able to lobby the ball without going too fast. We have not made a feeder yet, but we have multiple ideas, and we'll try to make it before the next competition.
For the cat ball lifter, we had two options: a ladder mechanism and a scissor lift. We decided to use the ladder mechanism instead of a scissor lift because the scissor lift wasn't that stable. We used the same mechanism that we used last year for our climbing arm, since we knew how well it worked. But this year we used servos and a rack and pinion format instead of pulleys with strings. We weighted the opposite side of the shooter so the robot won't tip over. We originally decided to use two individual arms with fingers to pick up the ball. But we then realized that the arms wouldn't fit the cat ball, and they weren't that strong. So we decided to go with a forklift design to hold the cat ball.